Here we are given the equation that represents the position of a particle. We want to find when that particle is at rest, when it is moving to the left, and when it is moving to the right. Well, we can derive both the velocity and acceleration functions if we know a particle's position function. The velocity tells us both the speed and direction that the particle is moving. If the velocity is negative, then the particle is moving to the left. If the velocity is positive, then the particle is moving to the right. If the velocity is zero, then the particle is at rest. So, we are given a position function. The velocity function can be found by taking the derivative of the position function. In other words, v of t equals p prime of t. Notice that this is the sum and difference of terms, so we can find the derivative by differentiating the function one term at a time. So the derivative of t to the fourth is 4t cubed. The derivative of negative 12t cubed is negative 36t squared. Differentiating 46t squared, we get 92t. Next we have the derivative of negative 60t, which is negative 60. And finally the derivative of 10 is 0, so we'll just leave that off. So when this expression is equal to 0, it means that the velocity is 0, so the particle is at rest. Similarly, when it is negative, the particle is moving to the left, and when it is positive, the particle is moving to the right. Let's find the zeros of this function. Notice that there is a common multiple of 4, so let's factor a 4 out of each term. Next, let's see if we can factor this cubic function. In this case, we can factor out t minus 1. This leaves us with 4 times the quantity t minus 1 times t squared minus 8t plus 15. Going a step further, we can now factor this trinomial. Factoring gives us 4 times the quantity t minus 1 times the quantity t minus 3 times the quantity t minus 5. Finally, we can use the zero factor property and we find that the zeros of the function are t equals 1, t equals 3, and t equals 5. This means that the particle is at rest at times t equals 1, 3, and 5. Now let's determine when the particle is moving right and left. The particle is potentially changing directions whenever it is at rest. So we'll set up a number line and divide it into 4 different intervals, marking each one of the zeros. Now we'll determine the sign of the functions for values in each one of the intervals. The easiest way to do this is by looking at the factored form of the function. The first factor, 4, will always be positive, so we don't have to worry about that. Now, let's consider a t-value that is between 0 and 1. If we substitute that value into the factored form of the equation, we'll have the positive 4, and then we know that the factor t minus 1 will be negative, t minus 3 will be negative, and t minus 5 will be negative. So we will be multiplying 3 negative values together, which will result in a negative value. Therefore, the sign of the function over the interval from 0 to 1 is negative. We'll repeat this procedure for values in each interval. In the interval from 1 to 3, we'll have a positive factor times 2 negative factors, which will result in a positive value. In the interval from 3 to 5, we'll have 2 positive factors multiplied by a negative factor, which will give a negative value. And finally, for t values greater than 5, we'll be multiplying 3 positive factors, so we'll get a positive value. Therefore, the particle is moving left over the intervals 0 to 1 union 3 to 5, and the particle is moving right over the intervals 1 to 3 union 5 to infinity.